friends, now look at the two types of multiprocessing systems. So to begin with, what is asymmetric multiprocessing, that is AMP. In this one processor, which is called master, controls the system and assigns tasks to other slave processors which perform only the specific duties. The processor which is controlling we call the master, and others we call the slaves. The slaves will perform all the duties that is assigned by the master. So here one master CPU runs the operating system, handles all the IO and manages the system. Other CPUs perform specific tasks assigned by the master. So they have a very small part of operating system that is sufficient to just communicate with the master and then take up the assigned task. The major activity is taken up by the master CPU, which is going to run the complete operating system. All IO activities are handled by the master, and the system, overall system, is managed by the master. Here the processors are not equal in capabilities or responsibilities. Major responsibility, major capability is with the master, and the slaves have a minor one. So working with asymmetric multiprocessing, the advantages are simplicity in design. The operating system complexity is reduced because it has to work with only one CPU and others just follow it. Easier to predict the behavior, good for real-time systems because we are working with only one CPU, and the behavior of that CPU, the overall performance of that is easily predictable, and hence it is good for real-time systems because the prediction and all can be done at a faster rate. So then it is efficient for fixed task systems like embedded controllers and all that. The disadvantages on the other side, it cannot be scaled. One master becomes a bottleneck. So if the master is busy for something, then everything have to wait for that. Inefficient CPU usage because the master CPU is always busy, and some CPUs may not get their chance at all. So some slaves may not get the chance, some slaves will get the chance. Master CPU always busy. So inefficient CPU usage and poor fault tolerance. If master fails, the whole system fails. So even if all the slaves are perfectly working, with no master working, everything just breaks down. So that's a problem with the asymmetric one. And we can't dynamically balance the load because there is only one master, and the master will statically allot the load to each of the slaves, so no chance of dynamic balancing the load. On the other side, symmetric multiprocessing, all processors are having equal power. Each one runs the same copy of the operating system, can execute any task, share access to memory and IO. That means one process is there and multiple processes are there, then the copy of operating system is available to each processor, and each processor can execute any task of the operating system. All the processors can share the same memory and IO. So that makes things real parallel processing, and all CPUs have equal access to the memory, IO, as well as the operating system. Shared memory system, it works with a shared memory system, so same physical address space is used by all the processors. No logical addresses, same physical addresses are being shared by all the processors. So any processor can run the operating system or any user task. So there is no restriction in which processor should do what. So any processor can take up any part of the operating system activity or can take up any user task. And the operating system here schedules the task across the CPUs using some symmetric policies. Now looking at the advantages, load balancing. A task can be dynamically spread across the CPUs. If you find that some CPUs are having additional load, then they can be shifted to other CPUs. Fault tolerance, even if one CPU fails, other CPUs can continue working because all the CPUs are working on the same operating system, all the CPUs are working on the same memory, all the systems can be working on the same process, all the system can be working on the same data, all the systems can be using the same IOs in parallel. Therefore, even if one CPU fails, other CPU can continue executing that task. So there is very good fault tolerance possible with symmetric multiprocessing, and we can have a better performance because true parallel execution is possible here. So when we have multiple processors, then each processor can take up its own share of the activity and parallelly each one can run, so the whole thing can be executed much faster. And simplified programming, because same code can run on any CPU, therefore the whole programming can be simplified. Other side, disadvantages. So shared memory contention, multiple CPUs accessing the same memory can cause bottlenecks. Yes, because at the same time two CPUs cannot be allowed to use the same memory, so there has to be only one CPU using any memory, so that if they try to multiple CPUs try to use the same memory, then that may cause a bottleneck. Cache coherence complexity, so maintaining the consistency across the CPU caches becomes a problem because the cache memories are inside the CPUs, and the CPU is working with one process, and then the data and the code associated with that process are stored inside the cache of that CPU, and after say time sharing and all that, if the next time another CPU gets chance to continue the execution, then all the data, all the information available in cache of one processor has to be transferred to another cache, and that's going to be a too complex process, so it becomes a complex in maintaining the consistency. So there is scalability limit. As the number of CPUs increases, synchronization becomes harder and harder, so it grows exponentially as the number of CPUs increase. This complexity of synchronizing them becomes exponentially harder. So overall, what you can see that the features, the asymmetric and symmetric, if you look at it, the processor roles, it's a master slave in terms of asymmetric. All processors have equal rights. In the symmetric, operating system runs on master CPU only in case of asymmetric, whereas all CPUs can run operating system. There is no load balancing possible in the asymmetric, but yes, load balancing is possible in symmetric. No fault tolerance in asymmetric type of multiprocessing, but in symmetric multiprocessing, load tolerance is far better. And use cases for asymmetric is embedded systems, real-time systems, whereas for system asymmetric things, general purpose multi-core CPUs and all. So that's about asymmetric and symmetric multiprocessing systems. Thank you.